Example 2, testing hypothesis regarding two population standard deviations. An investor believes that Cisco Systems is more volatile stock than General Electric. The volatility of a stock is measured by the standard deviation rate of return on the stock. The data in Table 4 represent the monthly rate of return between 1990 and 2018 for randomly selected months for Cisco Systems stock, and 14 randomly selected months for General Electric stock. Does the evidence suggest that Cisco Systems stock is more volatile than General Electric stock at the alpha equals 0.05 level of significance? So there is our information and our numbers for the data. So here is our data for Cisco, and then here's our data for General Electric. Now, what we want to know is if the evidence suggests that Cisco Systems is more volatile than General Electric. So symbolically, this is represented by the population standard deviation of Cisco Systems, which is population 1, is greater than a population standard deviation of population 2, which is General Electric stock. Now, we assume that there is no difference in volatility, so that means that the population standard deviation of 1 is equal to the population standard deviation 2. We want to verify that both variables are normally distributed by constructing normal probability plots, and then we're going to follow steps 1 through 5. So let's go ahead and take a look at the data on StatCrunch. So what I've done in here is I've already come in here, I put in the title Cisco and put in our data in StatCrunch and put that in GE. So first thing we want to do is we want to figure out at the QQ plots. So go to graph and then select QQ plot, and then we're going to select Cisco and then do the normal quantiles on the y-axis and then select compute. So we can see that all of our data is pretty close to a linear situation, so it's normally distributed for Cisco. Now let's take a look at the graph for GE. So we're going to select GE, select normal quantiles on the y-axis, and then select compute. And we can see that these data values are close to a linear situation. So then we can say that step 1 is valid. So therefore we can say that our graphs are valid, and here are our two graphs. So now, in step 1, the investor wants to know if Cisco Systems is a more volatile stock than General Electric. So this is written as sigma 1, subscript 1 is greater than sigma subscript 2. So the null hypothesis is a statement of no difference. So we can see that the null has the equality, and then the alternative has the claim, which is saying that population standard deviation 1, which is Cisco Systems, is greater than population standard deviation 2, which is General Electric. So therefore, from this, we can say that this is a right-tailed test. Now, in step 2, we know the level of significance is alpha, which is equal to 0.05. Now, in step 3, we want to be able to compute the sample standard deviation for Cisco and GE. So a quick way of doing that is we're going to go back to StatCrunch, go to Stat, go to Summary Stats, and select Columns. We're going to select both Cisco and GE, and then we're going to go and find the standard deviation. So we're going to select Compute. And there's our summary stats. So we can see here that the standard deviation for Cisco is 11.84. So we're going to square that. And then we're going to take the standard deviation for GE, which is 4.32, and we're going to square that. And when we divide those, it's going to give us a test statistic of 7.51. Now, for the p-value approach, we are going to use technology for the p-value approach. So we're going to start right here. We're going to use technology to obtain the p-value and the steps for testing hypothesis for comparing two population standard deviations. And what we're going to do is we're going to use StatCrunch. Okay, so I'm going to go back to StatCrunch. And so in order for us to find out what the p-value is, okay, we're going to go ahead and select Stat. Okay, and at Stats, we're going to scroll down all the way to Variance Stats. And since we have two columns, that means that we have a two-sample hypothesis. And since we put in the data, we're going to put with data. So now the first column represents Cisco, so we want to make sure that that's selected. And then the second column is GE, so we're going to select that. And so now the hypothesis test, okay, for the null, okay, that means that this is going to equal 1. Okay, and then in our alternative, we should have the greater than symbol from our hypothesis, our alternative hypothesis. And so at this point here, we're just going to select compute. So now when we select compute, okay, you're going to see that the number of degrees of freedom in the numerator is 9. The denominator degrees of freedom is 13. And then we have a sample ratio of 7.52. The F statistic is 7.52, and the p-value is 0.0007. So if we come back over here, we can see that here is the data from that given information. So this is what we found by following that instructions. So the p-value here is 0.0007. Now, since that is the p-value, we can say that if the statement and the null hypothesis were true, we would expect to get results at least as extreme as the results obtained in about 7 samples out of 10,000. So very unusual results indeed. So because the p-value, meaning this is 0.0007, is less than a level of significance of 0.05. So what that means here is that the p-value which we found to be 0.0007 versus alpha, which is 0.05, we know that this is less than the significance level. And if that is the case, then we reject the null hypothesis. So therefore, there is sufficient evidence to conclude that Cisco system stock is more volatile than General Electric stock at the alpha equals 0.05 level of significance. Investors should use this result to demand a higher rate of return on investments in Cisco systems.